name is Jonathan Brendefur, and we're going to talk about subtracting fractions now. We've already talked about fractions, addition of fractions, now subtracting fractions. So first of all, we're going to be talking about subtracting fractions with the same denominator, the same size unit. So an example is 5/4 minus 3/4. So again, initially when we're first starting to subtract fractions, we want to make sure that students are able to talk about the fractions correctly and conceptually understand it using a model. So our model or number line is useful. And we have our word wall up here. The numerator is going to be our count, our counting digit. The denominators are the unit size, the digit that talks about the unit size, which is how many equivalent units to compose one. Partition is to split evenly. And iterate is to copy a unit with no gaps and no overlaps. So in this case, we're going to first model 5/4, starting with the denominator. We're going to create 1/4 units. That means I have to create a unit of 1, partition into 4 equal sections. And then the count, I'm going to count 5 of them, which is also iterate. I'm going to copy 1, 2, 3, 4, 5 units. Each of these are 4th units, 1/4, 2/4, 3/4, 4/4, 5/4. Now, when we're adding and subtracting, we have to be in the same unit. So we have to, are we in the same unit? Yes, we're in fourths and fourths. So now I can take my 5/4, I'll shade that in to kind of show, there's 5 1/4 units, or 1, an additional 1/4 unit. Now I'm going to subtract 3 of those 4th units. So I can subtract 1, 2, 3 of those. I am left with this amount here, which is 2/4. So 5/4 minus 3/4 is going to equal to 2/4. Now we can leave it at that in 2 1/4 units. If we wanted to simplify that, we could also say, well, this size here is our equivalent amount here to get to 1. One of these is also equivalent to this same size, and 1, 2, which means that we could also partition the 1 into 2, or the halves, and that I have 1 of those. So 2/4 is also equivalent to 1/2. So again, it's focusing on the language and the modeling to make sure students understand conceptually, which in the future will really help them understand how to add, subtract fractions. They won't have misconceptions and have all these mistakes later on when they hit upper grades like 5th, 6th, and 7th grade, and will help them understand multiplication division later. Let's do one other example where the denominators are not the same. So we could have 3/4 minus 3/8. So in this case, we don't have the same size units, fourths and eighths. We want to be able to ask children, okay, the digit 8 is larger than the digit 4. What does that mean? They should be able to conceptualize and talk about through here that the 8 means there's 8 units to get to 1. Here there's only 4. That means that 8 is a smaller unit. So these are eighths are smaller. We need to get equivalent fractions. So I need to get fourths into eighths. So initially when modeling it, and we can talk later, we'll talk later about symbolically or algorithmically how do we get that. But right now, these are in fourths. 0/4, 1/4, 2/4, 3/4, 4/4. I have a count of 3 of these units, 3 of these 1/4 units. I want them in the same size units, so I want them in eighths. So I've partitioned each of these fourths. And then what's my new count here? 1, 2, 3, 4, 5, 6. 1/8 units is the same amount as 3/4. So I can convert 3/4 into 6/8. That gives me a new problem, 6/8 subtract 3/8. Now that I already have the 6/8 here, now they're in the same unit, same size unit, so now I can subtract them. So I'm going to subtract the 3 1/8 units. Get rid of that one, 1, 2, 3. And that is going to leave me right here, 1, 2, 3, or this amount here, which I'll make it a little bit more clear, 1/8, 2/8. This amount here is 3/8. So 6/8 taking away 3 1/8 units is going to give me 3/8. So 3/4 subtract 3/8 gives me 3/8. Okay, that is how we model and describe subtraction of fractions with unlike denominators.